Okay, ladies and gentlemen, as we begin Cluster 7, we're going to begin working with problems that are slightly more complex than the linear functions that we've done in the past. We're going to begin to work with quadratics. And in order to solve the problems, or some of the problems we're going to begin to encounter, it becomes very useful for us to start using factoring quite often. Factoring really is something that you've done in previous grade levels. So the basic concepts are nothing new, and really we're not going to bring in any new material for you here other than we're just going to show you how to do it with variables. So most of this first part of Lesson 7 really is going to be a basic review with some new information in a different way. That's really it, or some old information presented in a different way, really is more accurate. So just a very quick review. 42, when we factor, that's basically a way of saying that we're breaking things down into their basic parts. So really what we're doing is a division problem. So here 42, we know that 42 can be broken down into 6 times 7. So what we would say in the mathematical world is that 6 and 7 are factors of 42 because they can be multiplied together to give you that answer. Same thing now with a variable. We know that 3x is the exact same thing as saying 3 times x, and since 3 times x, either one of those can be divided out, they are both factors of 3x. Okay? So to clear that up just a little bit, that might have been just slightly confusing with the variable. As we come down here and we look at the number 56, 56 clearly is 7 times 8, 8 is 2 times 4, and 4 is 2 times 2. When we get to this point, all the numbers are now prime, so there's nothing else that we can divide out, which is the basic way of telling you that you're done. You can either do the factors in a horizontal line, or some of you may have been taught to do things in a factor tree such as this, which is perfectly fine. They'll both bring you to the exact same conclusion. 56 is 7 times 8, 8 2 times 4, 4 2 times 2. We're now prime, so there's nothing else to do, and you'll see we still get the same answer. 7 times 2 times 2, 7 times 2 times 2 times 2. No difference. The only new material here now is that when we introduce the variables again, 2x cubed y is exactly the same as saying 2 times x cubed times y, and we break those things, each individual term, down into its basic components. 2 is already prime, so we leave it the way it is. X cubed is x times x times x, and we have just a y to the 1, which is saying times y. So these are all the factors of 2x cubed y. You can't break it down any further, so that means it's your final answer. Using everything that we've talked about here, I'd like for you to very quickly, since it's all review, just do numbers 1 and 2. Take a few seconds and do those on your own. So what you should have ended up with is this right here. 40 is 5 times 2 times 2 times 2. 5 times 2, 10 times 2, 20 times 2, 40. And those are the basic factors of the number 40. Up here, here's the tree for it. You could have taken a little bit different route. Down, for 20, I said 5 times 4. You could have said 2 times 10 and continue from there. It truly does not matter what path you take along the way, because as long as you continue until everything is prime down at the bottom, you will end up with the exact same numbers, exact same factors, no matter what path you take en route. And of course, 50 is 2 times 5 times 5, so we've rewritten that here. N squared is n times n, m squared, m times m, and those are the factors. None of this information is really new, so we've gone through it pretty quickly. This brings the first video to an end. If you have any questions, please ask them now, and after that we will move immediately into the next section of factoring and take it from there.